Welcome to SmithWeekly Discussions, an occasional program for our members of SmithWeekly Research. Please note this program is a private discussion and everything contained herein is for entertainment and educational purposes only. With that, we hope you're in a comfortable position, along with your favorite beverage, to enjoy the discussion. We remind our audience to examine our show notes attached to each of our shows to better understand how our program functions. Before we get into our discussion, we want to say thanks for questions coming from our audience of SmithWeekly, including Brent S., Mike P., Luke A., and Andy J. We have a new guest on the program today, and one we're pleased to have join the program. Mr. Bill Kulish is with us. Bill is the founder, president, and chief technology officer of Steelike Concrete, an ultra-high performance concrete technology company that is advancing its proprietary design by supplying material to various industries that require new concrete structures, refurbishments, maintenance across the transportation, energy, defense, manufacturing, and mining industries. Steelike Concrete is based in Virginia, United States. You can learn more about Steelike UHPC and their work by visiting their website, steelike.com. Bill, thanks for joining us on the program. Welcome.
Very welcome, Andrew. It's a pleasure to be able to speak with you.
Bill, thank you. It's great to have you on here, and it's good to come on and talk and a little bit about some areas that is definitely familiar to our audience, and as well as other areas that they may not be familiar, and then also get into some of the technical details of UHPC and, of course, what Steelike is doing in this really new industry that a lot of folks still really don't know about. Maybe just you start us off here with a brief overview of Steelike for the audience, and then we'll dive into some specifics and applications.
Absolutely. Steelike, and the spelling is Steelike. The name comes from some of the characteristics that are inherent in the invention. I'll do very high level all UHPC, and I'll jump right specifically into Steelike. So UHPC, ultra high performance concrete. In the industry, we call it ultra high performance composite. It has no rocks, it has no gravel. It's all based on very little water, not too many additive chemicals, unlike the YouTube videos. If you Google UHPC, and it has its focus is on particle packing. So particle packing is you take a 5-gallon bucket, you can only fit in one basketball. You take out the basketball, you can only put in 1.5 volleyballs. You take that out, so many golf balls, and you just keep going down or sizing down, and you combine different size particles in different shapes, pack the particles to eliminate air, and then you need to bind all those particles together. Well, you don't just do it with cement. Cement to me is a boulder. So we have multiple proprietary reactive ingredients that when you're done, you're left with an extremely dense, very low air, below 2%. You freeze and thaw it 600 times. It actually improves in characteristics. It's waterproof. It's not water resistant. It's salt proof. It's not salt resistant. Because no water can get in because of the density, there's nothing to freeze. And if you don't have freeze thaw, you eliminate a lot of problems. It's an ideal material for caustic, environmentally tough environments, caustic environments. And when you try to abrade it with an ASTM test, the pad that you use to abrade it and test it with wears out. Everybody's mind, they can use their imagination. I'm holding up a shell of a 50 caliber bullet. Steelike has repetitively has stopped 50 caliber bullets at 50 yards at 2.5 inches. The other bullet I would hold up would be a 308 hollow tip, green tip. 1 inch of Steelike has stopped that bullet. And when I say stopped, I'm not talking about shattering into shrapnel. I'm talking because of one of its great tensile properties, it's absorbing that energy. You know, a 50 cal is 12,000 joules at 50 yards. It absorbs that projectile, and you can pull the projectile out with the firing rings still on the bullet. It's a remarkable thing to see. As far as Steelike, compared to all the other global UHPCs, which I dove into over the years, we shrink half as much as one of the older brands, less than 427 microstrands. We're talking a couple inches over a football field. There's so little water that most, or I would say 20 to 30% of it is starving the mix. So you actually end up with unhydrated binder. And what does that mean? Well, that means that binder becomes a filler unless it gets exposed to water in the future. So you end up with a self-healing property that you will not get in traditional concrete, where they overhydrate it. And then there's a lot of voids that are left with the extra water evaporating. So Steelike itself, compared to other ones, and then I'll pause, it shrinks half as much as all the other UHPCs. When you freeze it and thaw it, it improves in many of the characteristics. It hydrates the quickest. You can get traffic on a bridge 50% faster than any other UHPC on the planet. Now, I'm a very animated individual, and I tend to get excited about the material because it is exciting. But everything I'm going to mention today is backed up with years of science. So this is no more just my excitement and opinion. This is scientifically backed up. So our biggest difference would be we're an all-white material, which allows pigmentation. Our material allows traffic, loads, strains 50% faster than any UHPC I'm aware of on the market, certainly the leading brands. We shrink half as much. Our impact resistance is stronger. It's white, so it can be pigmented. And for purity reasons, the gray concrete, why it's gray is the impurities. So if you made something with Arizona gray concrete, it would have a purplish hue. If you make it with Pennsylvania cement, not concrete, if you make it with Pennsylvania cement, it would have a greenish hue. I eliminate all the risk of the inconsistencies of the raw ingredients by going with all clear or all white material.
Bill, thank you for that. Lots of good information, and I want to come into some of it here in a moment. Probably geared towards some of the other areas that we should discuss, which is PSI properties, all the test reports and stuff on this. You guys already have lots of data on this to back up what you're saying, as you indicated as well, but also longevity, resistance to things like disasters, earthquakes, that ability to have long life compared to conventional or traditional concrete. And of course, in the US specifically, we have very, very much aged infrastructure that has not been reinvested in for a long period of time. Most of that's due to policy, poor policy. We're seeing some changes on that front and some government funding on at least the government responsibility side of infrastructure. Lots of stuff to talk about. Let's move into some of this here because that's going to come up in some of the conversation, but I want to just have you talk a little bit about your background, Bill, and experience in concrete technology and how that formed what Steelike is today.
Thank you for the question, Andrew. Approximately 2 decades ago, 22 years ago, I was focused on architectural panels, decorative concrete, cladding panels, and through my research, I realized that traditional concrete had a terrible life cycle cost. It not so much planned obsolescence as much as I was walking into an industry that inherently was making 5,000 psi, pounds per square inch of force that would cause failure, catastrophic failure. 5,000 psi concrete, which is what all of us probably are driving on today if we're driving on concrete pavement or roadways, tunnels and bridges. And my goal was to create a material that had far superior properties. I'll briefly go into carbon footprint, but it ties into your question, Andrew. Talk about reducing carbon footprint. If you make a material that unintentionally is going to last 5 or 10 years before it needs repair, you factor in inflation and you factor in traffic jams and detours and everything else. Fixing something, as all of us know, if we've done anything in our houses, is always more expensive than putting it in fresh or replacing sections of it in whole. So when you take a material that has all the characteristics that we were talking about: freeze-thaw, salt resistance, impact resistance, abrasion resistance. Um, and you do one of four things with it. You repair, you replace, you reinforce slash harden for protection, repair, replace, reinforce, or restore with a material that has a predictive life cycle of over 100 years. If you build a bridge or utilize Steelike UHPC on repairing an existing infrastructure that we mentioned, and you factor in inflation, the material has a negative carbon footprint after about 50 years. So the mindset has been patch it, fill the pothole, patch it. The bridge has exposed rust from salt that's used to melt the ice in the winter, blah, blah, blah. And you're driving underneath the bridge and you're seeing rust dripping down and staining in concrete. You can encapsulate that section with Steelike and fossilize the damage, strengthen the very hole that you patch, eliminate oxygen and moisture from getting to the steel, fossilizing that damage. And if there's enough steel left, you've replaced the tooth instead of just patching it with a cavity.
Talk a little bit more on how that has all come together and why you saw the purposes of, hey, we should launch this technology is really extraordinary. We should
Absolutely.
launch and get into this business and launch Steelike because of the market demand for this new technology, which is it's a superior technology by a long shot, in my opinion, based on what I know about it. And obviously, you believe the same thing. Otherwise, you wouldn't have started the company. But talk just a little bit about that.
So over 2 decades ago, I started experimenting with different raw ingredients. And once the light came on about using the purest stuff available, I realized that over 50% of a true UHPC, again, you Google UHPC, you're going to see every university, the FHWA, many guys in their garages have UHPC or claim they have it, and they do. Some of them do. The academics tend to prove it in very small batches. KitchenAid mixers, Hobart mixers, you're making less than a cubic foot per batch in a controlled environment. The weather is 72°F. The moisture is conditioned. Everything goes perfectly. And then you go out and you try to do a bridge with it, and it's a totally different experience. So over 20 years ago, once I created Steelike, I looked at the existing material, and it was really only one player in the United States, and they had a 20-year history globally. I contacted that company and said, I'd like to use your material to make things with it. And they said, sure, $30,000 a year licensing agreement. You have to buy our specific mixers. You have to, and then the licensing agreement was 3 inches thick. So I looked at that and said, well, at the time, Andrew, I'm not interested in infrastructure. I just want to work with cladding and decorative concrete. So I locked myself in my studio and proceeded over a 3-year period, came out occasionally, to dial in the recipe. Once I dialed it in, being from the decorative world, cladding, skinning, cosmetic things with some structural capabilities, I made a playable concrete record. Again, I mentioned there's no rocks. Everything is fine particles. So I rubber molded an old Christmas album, Burl Ives and Miles Davis. I filled it with my material and I put it on a record player. And of course, it sounded like garbage, but it pulled that detail so significantly. And the record bent and it didn't snap when I put it over my leg. So I took it to the world of concrete. This is the elevator. I'm coming down to the first floor. Thanks for everybody's patience. I made a playable record, went to the world of concrete on a whim, set up a record player, and just started playing it. And then I had several hundred people standing in line. One of the people in line, I later found out, was from Fort Knox and the Corps of Engineers. And they have been experimenting with UHPC. They've since sold their invention. It was a patent. They sold it to a private holder. But at the time, they were, for obvious reasons, vigorously working on an internal mix design called ultra high performance concrete. And the next thing I know, I'm at Fort Knox and we're making hundreds of yards of it. I have an NDA. I can't speak to what they did to it, but it was Fort Knox and it did very well. And the FHWA heard, Federal Highway Administration heard about this new competition to the only, at that time, sole source publicly available material. And they put out a specification to build 35 and 60-foot giant girders to replace steel girders because it doesn't rust, it flexes, so on and so forth. That was very successful. And then the different departments of transportations heard about it. And I was invited into the scientific community of UHPC globally and started going to many conventions and interacting with the experts on this material. And then one DOT specified it, and then it was put into another. And now I'm glad to say we've done well over 50 bridges throughout the United States. We're pre-approved in every state that allows it, because as Andrew mentioned, it's relatively new, so to speak. And I'll finish with this, Andrew. Up until October of last year, there was no recipe for a bridge engineer or a structural engineer to use this material on anything, other bridges and otherwise. They would basically be specifying it, and it would be based on their reputation and what they thought this material could be used for. Well, that held up the market. And in October of last year, the FHWA working with AASHTO actually now has a structural design guide for specifically UHPC. So now every engineer in the United States can go to that design guide, thanks to people like Ben Graybill, who leads the FHWA research on UHPC. They can now go to that guideline and literally reference the data and all the tests they've done over the last 10 years, a lot of which includes steel-like material. And I'll finish with this. As we speak, if you picked up the phone and called the FHWA and said, hey, are you testing steel-like? Their response is going to be, we are a transparent organization. We cannot promote any material over the other, but I'm allowed to say, because I live 30 minutes away from the Turner Fairback Research Center in Virginia, where they do all the testing, I can say that my material is up there in their lab, has been for many years, and they just ordered more material to continue doing research to publicly document it.
We've got a good indication here that there's a lot of infrastructure use, and right now, one of those target markets initially has been the transportation side, but as we started to get into, there's so many other applications, and I want to discuss that in a moment. And then just also the point that this is being written into a lot of specifications, and there's been specific steel-like approvals in specification, but also that there's a lot of participation in new specification development for UHPC in general, which
Yes.
Steelike is very much involved with the designing of those specifications. And that further, the United States still would be one of those probably, top 3 to 4 jurisdictions for quality of specification. Maybe a little bit burdensome depending on what type of specification we're talking about, but in general,
Sure.
It's widely accepted, and obviously it's referred to quite often outside of the United States. Those specifications tend to be the gold standard in a lot of jurisdictions as well, depending on what industry specifically we're talking about. But yeah, on applications, so we understand definitely transportation's in there, but cover off maybe some of the other potential civil applications. We've talked a little bit about defense, so we know there's some areas on the defense side, hardening of infrastructure, but also the potential energy and mining applications as well, precast. There's a lot of different things here, but just talk some of the other areas that you believe that there's a very good target market that is being entered into and that also needs further development and progress.
Based on the life cycle, cost and life cycle of this material, 10, 15, 20 times better than traditional concrete. The other perk of that and its characteristics, Andrew, is the reduction of the need of material. some engineers, some friends of ours over in Ukraine, analyzed this material's characteristics. They have a big problem with old buildings that have signs on them that say shelters, and people, go into the basement, and it's basically, made out of fly ash cinder block, and something happens to the building above, and it pancakes down, and it's very unfortunate. They did a pretty strict analysis on what it would take to harden, strengthen that basement to turn it into a legitimate shelter. With traditional concrete, it was well over, they would have to eat up 3 feet. They would have to put in 3-foot walls and 3-foot ceilings in order to harden it. And when they did that, they basically run out of room inside the cavity. So when they analyzed Steelikes, they realized they could achieve the same thing with 11 inches. And it could be pumped down, or it could be just gravity. This stuff flows like pancake batter or lava because there's no big rocks. It's a very fluid mix when it's in the fluid state, the plastic state. So one application would be reinforcing existing structures. Let's talk nuclear. There's a Canadian material scientist. I don't have his name in front of me. And other scientists throughout the globe have been analyzing the density of this material, and they find it to be extremely promising for not just hardening, but for containment. I currently have 6 NDAs with multiple companies in the United States, so I can't expand too much. But what I can say is this material, its density, its density alone, and because of the particle packing and the lack of air and the type of fibers that are used, definitely resist radiation much 50 times plus that of regular concrete. So that would be another application in the future. And the future is not that far away now that there's been quite a bit of research done on it specifically. So that would be tunnels. If you're building a new tunnel, you would have to core out probably 40% less earth to put the tunnel in, which means you don't have trucks having to burn fossil fuels to take that dirt away, and then you don't have somewhere to put it, and then you're using less material. And because of all the characteristics, or most of the characteristics I've talked about, you could line that tunnel with 40, 50% less material and end up with something that's considerably stronger, much more resistance. It would be laying a waterproof pipe that would not see moisture, that would not see chlorides or anything else that could happen. So tunnels, if you want to strengthen a tunnel, Steelike has invented, based on my research, the first specifically designed pumping and spraying system for UHPC. What does that mean? Well, traditionally you pump, whenever we drive by and we see a big truck with a big boom going up 20 stories and they're pumping concrete. That doesn't work for UHPC. UHPC, as I said, is very dense. It has very little water on purpose for unactivated hydration. It's all by design. And that's what gives it most of its characteristics. You can't pump that stuff with piston pumps because it overheats because of the friction. There's so little water, it's not very fluid. So you would start cooking the material, and then UHPC is unique with other materials. They use a very high tensile, needle-like high tensile steel fiber. It's a 1/2 inch long, and it's 0.2 millimeters in diameter. It's basically a hypodermic needle that's not hollow. And that micro rebarb gives it tensile properties beyond belief. That being said, and it holds it together, and it stops cracks from propagating, from being microscopic to macro to visual. So those fibers are a challenge in a pumping system. So we have, and we've used it on DOT projects, we have the ability to do shotcrete UHPC and pump it. So let's go back to a mine. Let's go back to, instead of putting 1 foot or 2 of traditional concrete, shotcrete, which generally doesn't have fantastic characteristics, at least not compared to Steelike. you could go in and shotcrete the walls or the lining of that and get all the benefits that we've been talking about.
On the mining side, you can see the underground benefits there. There's applications for underground mining, and then open pit conventional, certain structures I would suspect would also work. You could potentially look at liners as well, but also tailing storage facility applications as well on the
Absolutely.
conventional side. And then on nuclear, and I want to come back to what you started to come into a little bit here and get more on the economics, but certainly for commercial reactors, whether we're talking the potential for SMRs, which haven't been deployed yet, or things like refurbishments, maintenance, and even new build construction, which is obviously happening on conventional reactors globally, more so
Yes.
today than even a couple of years ago. And then there's been further commitments. Just most recently, there's been commitments from major banks around the world, Citibank, Morgan Stanley, Goldman Sachs as a couple examples, pledging to now get back in and say the N word, and the N word is nuclear. And that is now becoming very important for the realization that, hey, we need good, solid quality of energy, and that it doesn't get any better than deployment of commercial reactors. And so with that, let me come into the area of the economics bill and move forward to that real quick, and then we'll come back to some other things. So
Sure.
UHPC certainly reduces quantities of material. You have thickness reductions over conventional concrete. You have substantial increase in lifespan, substantial improvement in overall characteristics and properties. Maintenance is likely reduced over that period of time in many applications. Talk a little bit about those benefits. Maybe we can talk a little bit more about properties in terms of strengths and what you would expect on longevity. The reality is we don't have 100 years of tests yet, but we can certainly
Sure.
say that in some applications, 100 years is certainly doable on lifespan and duration. But also the cost analysis, where does that fall into incentivize end users to go with UHPC over conventional concrete?
Absolutely. Over 20 years ago, they put pylons into brackish water off the northeast coast of the United States, and it went through freeze-thaw cycles. Of course, it was brackish, so it had chlorides. It was low tide, high tide, so it was dry, wet, dry, wet. After 20 years, and this article is available, I can send Andrew the link after our podcast. They took out a column and they analyzed it. They dissected it. Inside the column was high carbon steel, which, like an apple, if you bite into it, oxygen and H2O, it's going to oxide, it's going to rust. The metal was shiny and new. The amount of penetration after 20 years was less than a quarter of an inch. Based on that abusive environment, they could run models and predict that this column, before it had any structural concerns, could last over 1,000 years. Now, that's one real world test. As we all know, labs have the ability to do accelerated testing. So they put it in extremely caustic environments to accelerate what nature would do over decades. And that's where these life cycle costs are coming from. Um, we are told in the community when we're doing a presentation to say 75 to 100 years. Why? Because Andrew's point is valid. This stuff hasn't been around for 100 years. And the community doesn't want people feeling like they're exaggerating, but the science backs up that it's 75 easily, and certainly most likely over 100 years. So now we'll get into strength and cost is huge. So I'll start actually with cost. Looking at life cycle cost, the material is more expensive. Point blank, you can probably get a cubic yard in the United States delivered to your house of traditional highway concrete, probably $300-400, depending on how far and such. UHPC globally is going to average, the material itself is going to be closer to $2,000 a cubic yard. And then in America, you must use Buy American Act steel fiber. Those fibers that give it its tensile property. They don't affect compression. They don't affect anything other than the ability to flex and adapt and give and stop cracks from propagating in the future after heavy loads or impacts or blast. Those things are expensive. They're like $3 a pound. And you're putting in, and you need to put in about 265 pounds of that So that times three is over $1,000. So all in, you're looking at a cubic yard of a material that, on average, for medium volumes, could range between $2,500 to $2,800 per cubic yard, knowing that almost $1,000 of that almost is steel fibers by American Act. It's much more expensive. It's investing in the future. When I was invited to go to Estonia to speak to a 100-year-old tradition, it's a meeting. It's called Concrete Day, and from that presentation, I was invited to go to the leading power company in Tallinn, uh, backed by unlimited amounts of research. We walked into a room and I was speaking. There were 9 people. 7 of them were structural engineers. One was a nuclear physicist. What was going to be a half hour of time because of translation challenges turned into a 3-hour meeting. They were bringing out plans and showing of the small fission or small plants that they were seeking approval for. They've received approval afterwards. We started looking at it, and I barely had to say anything. They were familiar with the material. I had done a presentation. They had the data. They had all the test data. And they were saying, we could use it here. We could use it here. We could use it in containment. We could harden this structure. We could free up more space by having smaller pylons. The wall thicknesses could be less. And the conversation went on and on and on. Then we got into containment. They're storing waste in really thick, old walled, thick concrete boxes, so to speak, sometimes a dome in other countries. And they were talking about their existing structure could be further protected, but for new construction, as Andrew correctly mentioned, it could be a game changer. So is it more expensive? Absolutely. Is it more expensive if you amortize it over the life cycle? It's actually less expensive. A good friend of mine, professor at University of Texas Arlington, Simon Chow, he was asked to do a proof of concept on an airway run in Houston, airway runway. They took out, as you know, their giant blocks, they're giant panels. They're not just one contiguous pour like on a highway in the United States. They took out a normal section of traditional concrete. It was 14 inches thick. They compacted soil underneath. They put in 8 inches of a UHPC test panel. It ended up doing the normal replacement would have been $500,000. Doing the UHPC precast placement ended up being closer to $300,000. And they're not going to have to replace that thing for most likely hundreds of years. So that's just an idea of what is the cost up front. Is it an investment in the future? Yes. Are the people that specified today going to see the benefit in 100 years? No. Will their children see it? Will the planet be a little safer from certain risk? Yes. That would be my answer.
The upfront cost right now compared to traditional concrete for sure is going to be more, but I'm very much interested in looking at what is that kind of cradle to grave cost, if you will, or the total life cycle cost. And I think that's where it really adds up. And then, that analysis on the front end of, okay, we can reduce that slab, from 14 inches, down to 4 or whatever that number is, understanding
Sure.
what that is. And then also figuring out, so you have less material costs, you have less inputs, you have potential to speed up schedules. So like instead of
Yes.
waiting for 28 days to let concrete cure out and then you've got to go through all the tests, maybe there's the potential to improve that where you don't have a crew that's on standby or having to go somewhere else and you have some of those logistical issues you can fix up. Total saving, then you look at that lifespan increase. So traditional concrete at best, sure, I think you and I could probably think of some bridges and even some dams, hydroelectric, that
Sure.
are on 50-year life already with the concrete that was, and of course they got lots of problems, but
Sure.
that increase of lifespan and how that looks, and then of course your overall usage, speed, and all those things that really play into this. And so you have to analyze it like that because I think that's the big sale point. And when you have We know that solar projects and wind projects, which potentially could have steel like or UHPC style applications, potentially. Railroads is another very interesting one when you come into the discussion about railway infrastructure that's really quite aged and falling apart in the United States, and what applications can happen there with ties and potentially rail. But
Yes.
also that when you look at something that you're installing that's meant to be, as long as possible, railroads, for example, you look at a new conventional reactor, and a lot of new conventional reactors are looking at a minimum licensing period, at least initially out of the gate, of probably 60 years. In some jurisdictions, 80 years. And there's consideration for 100-year license operating periods. And we know that things like applications like wind and solar require constant maintenance and even replacement, probably depending on where the location is and the elements involved in
Yep.
terms of weather and wear and tear, and then also impacts on environment of maybe 10 years, maybe 15 years on wind and solar installations, which speaks to, at least from my desk, that these are not practical. I mean, they still get built because most of them are subsidized, but they're not that practical compared to some other forms of energy from this desk. We've looked at it too many times to go cross-eyed. Nonetheless, it's being built and governments are promoting it, even though it is inferior. There's still applications for this. And of course, that's where UHPC is indifferent to the type of energy that it might be supporting or the source of energy that it is supporting. But I think that's very important to take a look at that and understand that. So you did talk about what the material is on basically a cubic yard material only basis. Installation cost, of course, is going to vary greatly depending on if it's a bridge, if it's a deck floor overlay, a shotcrete application. It's obviously going to vary substantially depending on the application. One of the other things I wanted to come back to, and I want to come into the company here in a moment and talk more of the company side of things. One of those other questions, Bill, is talk about why Steelike's UHPC intellectual property is superior to competitors, and talk a little bit about that market as it stands with competition for UHPC products. This is definitely an earlier stage market that has a lot of growth ahead of it. But just talk about what you guys see as really your competitive advantages at this point, and how you guys stand out from the competition.
One word would sum it up, and I'll debrief my own word, which is time. As Andrew mentioned, the airport scenario took 4 days, and they were landing planes on it. Uh, the time savings is really what drove a lot of the overall cost compared to what they traditionally do. We did an overlay in Oregon. Uh, Traditionally, with UHPC, you put down 2 inches of material. Think of a bridge as a broken tooth. You don't rip out the tooth and put a new tooth in. You get rid of the decay and you put a coating on it. That's what we did in Oregon, but we did it differently than our competitors could. And our advantage and why they went with us is this was a major access um, to a small city, but nonetheless 4-lane traffic, large trucks, and they had to get it done quickly. Every hour that a bridge has a detour, the impact, again, I'll keep saying carbon footprint, but the impact on society of having to go around it or wait in traffic and idle for 2 hours, not to mention potential emergency situations, is a very expensive process. So we came in on a Friday. They prepared 2 of the 4 lanes of traffic, closed them off. They scratched it up. Technically, they hydro demoed it to make sure there was no more decay. We came in Saturday, put 2 inches on it. On Sunday night, they opened that side of the bridge to traffic. We came back the following day and did the other side of traffic. What made us unusual was we were discharging and mixing from the same ready mix truck. Most of our competitors, although one of the bigger competitors is now paying homage to Steelike. After 20 years, they're trying to, and they're starting to be successful at mixing and placing out of the same ready mix truck. But that wasn't the big savings. The big savings is after you put down the 2 inches of material, which has to hold the pitch of the bridge. No bridge is flat, right? There'd be ice issues. So this thing has a pitch. We're putting down a non-Newtonian fluid almost. We're putting down a material that's thixotropic. You put it down, It moves under its own energy and then it stops flowing. One of the unique differences of Steelike over all the other UHPCs, and one of the advantages to people utilizing it, is that non-Newtonian fluid state can be manipulated in such a way that we put 2 inches of the material down. Normally, there would be imperfections. The specification calls for 1/8 inch tolerance in deviation of height over 10 feet. So for every 10 feet, it cannot go up and down up 1/8 of an inch. Normally, you wing it, you put down, and it's going to be sometimes a 1/4 inch, a 1/2 inch too thick, and you have to profile it. You have to grind the entire surface so that it's all the same plane. By utilizing Steelike, we were able to apply it working with a great contractor that understood the process. We worked with him closely. There was no profiling required. What did that mean? Well, that meant they didn't have to spend a day grinding it flat or flat to itself. All they had to do was put some grooves in it so that it had more friction during snow, ice, or rain. And that saved everybody 2 days worth of grinding. The environment benefited because they weren't launching dust into the air. When they grooved it, they could capture that dust. And that bridge was open to full traffic, 40-foot tractor trailers going over it, as we're standing on the other side of the bridge applying that surface. So our biggest advantage would be the savings of time, the reduction in labor, the reduction in environmental impact, and we're placing what scientifically has been documented as a material that shrinks less, cracks less, abrades slowly, and it's waterproof and saltproof. That would be our advantage over all the other UHPCs.
From my understanding, and I haven't spent a lot of time on this compared to you, of course, but there's a number of groups out there, the incumbents, which include Steelike, but also other groups that are in related industries or in material, basically construction materials, if I can just collectively, that's not the proper terminology, but that's what I have at the moment, that
Sure.
are looking to enter into these other technologies and add these other products and these other technologies into their conglomerate. Chemical manufacturers, for example, and there's a lot in the U.S. that I can think of. I'll just refrain from the names, but I'm sure our audience can think of a lot of them because they've seen them.
Sure.
Whether you're a retail person or a person in the industry or an investor in the mining industry, you know a lot of these are pretty much household names over here. Talk more specifically a little bit on the properties for us. You don't have to go into too much detail here, Bill, if you don't want to, but on some of the properties, include also, we talked earlier that conventional concrete in the construction industry infrastructure is somewhere around 5,000
Yeah,
psi today.
sure.
Talk about the properties on that side as far as psi strengths, and then some of the other key properties you talked. Freeze thaw obviously is a big deal, and this has incredible properties there. But just talk a little bit more about that, and then we'll move into the company structure.
Of course. So PSI, that's the buzzword of the industry, right? When you talk to anybody that knows nothing about concrete, or you YouTube good concrete, or you research concrete in itself, it's given a value, and it's pounds per square inch. And my apologies for the people that know, but I'll high level for everybody. You take a square foot of concrete and you cut a 1 cubic inch cube and you apply pressure to it. At what point does it destruct? Does it break down catastrophically, blow apart? So there's two different factors here. One is catastrophic failure, and the other one is limited failure that can still sustain the load that broke it initially, and in most cases, certainly in the case of Steelike, can exceed the load that broke it. So what does that mean, Andrew? That means 5,000 psi on traditional concrete, it blows apart. I don't care what kind of fiber you put into it, it just catastrophically fails. If you and your family are driving over a bridge in an earthquake, you want as much warning as you can. And that's one of the reasons they're putting rebar in. The rebar it's called strain hardening. It'll take a load. Before it snaps, it'll stretch, it'll give, it'll bend, it'll hold on for dear life. Once all the bar snaps, the bridge collapses. Strain hardening is the ability of the material, like steel, to sustain the load and exceed it, the very load that broke it. So what is Steelike UHPC? We have had real world labs where they pull cylinders right out of the truck on the bridge in every environment exceed 26,000 psi. At its very lowest number, which I'll explain briefly why just the strength alone is not UHPC, we average 22,000 psi. Now, you apply force, and that force could be a 50 caliber bullet. It could be a tank projectile. It could be a truck. It could be a train. It could be an earthquake. Any force you can imagine. And you apply a force to Steelike. The first thing you're going to get is microscopic cracks. Now, because of the high content of these steel fibers, micro rebar, when a crack starts to try to grow, it hits another bar of steel, micro steel fibers. It gives up and it goes into 6 directions. And now they're back. The cracks are so small. My point is that it's waterproof. No concrete, when you see a bending concrete, it's not bending, it's cracking. The cracks are allowing it to move in such a way that optically it looks like it's bending. The reality check is it's cracking. But what's amazing about UHPC and Steelike specifically is you apply a load, there's millions of microscopic waterproof cracks that won't even let water or salts or chlorides or alkalines get in, or oil or any other substance. It cracks, and visually you start to see a deflection. But you can add more weight than what cracked it initially. It'll continue to deflect. And you can take the weight off and it'll recover. And if there are any cracks, most of them close up. If they don't close up and it gets exposed to rain or water or moisture, it heals itself. It forms new crystals. So Steelike has a scientifically proven reputation, a validated reputation of having better characteristics as it pertains to strain hardening, flexural, better characteristics as it pertains to freeze thaw because it's waterproof, better resistance to chlorides, salts, de-icing agents, and that would set it apart from the competitors. Now, the competitors are great material. It's not like they're 50% worse or 50%, or that we're twice as good. We simply meet and exceed any standard in the United States, and we just got some testing saying that we meet and exceed standards in several other countries, above and beyond the legacies that started UHPC 25 years ago. It's blended in America. It's an American product, period.
Bill, talk about these steel fibers just a little bit here, as far as the U.S. origin steel fibers specifically, as far as tensile strength and just some of the properties surrounding that, because that's a key ingredient here as well.
Yes, sir. So these fibers are not made specifically for UHPC. They are made for tires for the most part. Bicycle tires, motorcycle tires, steel belted radials, the tires that all of us have. If you cut it open, you will find a long string of these fibers. They have to be forged in the United States, at least for projects being done in the United States. The fibers, on average, have a tensile strength of 400,000 psi, 400 ksi. Why? The material on its best day might be, let's just say, 30,000 psi. You got something that's 10 times stronger than you think it would need to be. Well, you apply a load. I've talked about how the energy starts to propagate cracks within, and it hits this outrageously overkill fiber when you first look at it. And then you realize the compression of that burst of energy. You have all this force that caused the material to start to crack, and that far exceeds 30,000 psi. I mean, jump off a 4-foot wall and jump onto a scale. It's that initial burst of energy that fiber has to deal with. It certainly has to be much stronger than the material it's within. So the Buy American Act fibers are in the United States, you have to use them. There is an exception, and that's privately owned bridges, but quite often they'll still request the Buy American Act fibers. If you bring them in from overseas, they're half the price. They are the same composite. It is the same metal. It is the same process. It's a drawing process. You start off with a 1-inch rod and you squeeze it through a smaller opening. And every time you do that, you're strain hardening. You're forcing the molecules tighter together. And the PSI, the tensile strength, goes up and up and up. So when you go from a 1-inch rod down to 0.2 millimeters, it is so high tensile, it's off the charts. You put that into my material and it allows it to carry loads, and it resists blast and the propagation of cracks that eventually become visual. And they're very expensive.
Quite interesting to me, these little steel fibers and how they play a big role in this. So appreciate the comments there. Moving on to company structure and strategy, Bill, just another area of discussion that I think some of our audience will find also important to them as they listen to this. Just talk a little bit about some of the key staff at Steelike that you want to mention that is supporting your work and, of course, the work of the CEO.
Andrew, I'm going to give you what it was a year ago and what it is today and why. So a year ago, we had 4 salespeople, full-time salespeople. Uh, my wife is our CEO. She has an intellectual property background, M&A, after spending 17 years with DuPont. Um, Very culturally sensitive. She brings an incredible force of positive energy to the company in any negotiation. She's negotiating for both parties. I've never met a person, yes, I'm biased, but if I step out of this and I look at her ability to want everybody to equally benefit and not just be a Steelike win, it's remarkable. So that's my wife, Chen Wong. She's the CEO. We have, of course, a CFO who also wears the hat of the COO. We have myself. A year ago, we had 4 full-time salespeople, a paralegal, because a lot of these projects in the United States, United States very litigious. It's negotiating the contract. A lot of the contractors, well, most of them, we're introducing them to it. But there's contractors that embrace this technology and say, this is different, teach me how to use it. And then there's contractors like, I'm just going to do what I've been doing for 40 years. Well, the 40-year people with all that expertise that doesn't apply to using this material, it's a composite, it's not concrete. They can take months of education. So that was our structure: paralegal, CFO, CEO, myself, 4 salespeople. Now, for the people that are actually placing the material on the bridge, my team quite often includes myself. I, I love being there when I can be there. It always includes highly trained, certified people that have done multiple bridges with me present that I certified. So we have an entire staff of 1099ers, guys that love doing this. They get paid adequately, and they will come. We will fly them in to whatever state the project's in. And again, when I can, I go. This year, we fine-tuned it down. We've taken Steelike as far as we can in the United States with the current demand, which is going to be increasing now that they have the perspective specification I mentioned from AASHTO, a perspective spec, a handbook on how to use this material thanks to the FHWA. We've cut it down to myself. We have our 1099ers. In fact, they're on a plane right now coming back from Oregon. They're about to go to New York and then to New Jersey. And we have our CFO, and we have, of course, some internal administrative assistants. So we've streamlined the company. Why would we cut out salespeople? What we realized is this material is not a material that's conducive to having somebody call up a contractor and say, are you interested in UHPC? This material is being specified. So we're now solicited by contractors. The word's gotten out about Steelike. We're solicited by contractors saying, we have a job, we have to use UHPC. We would like you to support the project, supply the material, and provide technical support. When we had 4 full-time salespeople, they were calling, and quite often they didn't completely understand the uniqueness of this material, and it became more of a price conversation than it did, let me explain why, as we've had in this podcast, Andrew. So we've filtered the company down to where it needs to be running smooth and low, and we've reduced our overhead significantly. And that's the current status.
Bill, talk a little bit about the strategy going forward here in terms of your desire to grow the business as a private company, but also from, of course, the view of interest from potential interest from larger chemical and material manufacturers in the United States or elsewhere who want to gain entry into the UHPC marketplace. We know that there's some out there that haven't got in, and there's some that are reviewing that as well. But what do you see as the preferred outcome for Steelike, Bill, as you move it into the next stage of business growth?
Good question, Andrew. So my wife and I, we look at this as we gave birth to a child. And 20 years ago, we created Steelike. And then it took 10 years to get vetted. And then in 2014, I mentioned the Fort Knox. That was our entry into the non-decorative world, the non-cladding world, right? Which was really the original intent. It's been vetted. It's been proven. As I mentioned, we're pre-approved in every state that allows it. We've done well over 50 bridges at this point. We have many more on the books. We feel that we've taken Steelike as far as we can take it with our resources. And the next step is beyond bridges, in addition to the bridges. Now, the United States put UHPC in a bunch of cow fields 15 years ago. They put a bridge in Canada. They put a bridge in Iowa. New York started adopting it. And all of those, because there was no, again, design script for engineers, all of those were trials. All those were proof of concepts. Oregon did their first project with us. When I was on the bridge, I'm talking to the main guy for Oregon, and his wording was, this is just so we get comfortable with this material. We see applying it everywhere, in some way on most of our bridges, right? So we feel that, my wife and I feel, we've taken it as far as we can, knowing that the potential beyond bridges, in addition to the bridges coming, the potential far exceeds our current capability to fund it, to take it to the next level. Case in point, I spent a month overseas. I went into Poland. I visited a military base. I then went to Estonia, did that presentation, then went to Finland. And in all the Nordic countries, Andrew, you don't drive on concrete. To my surprise, they bury inferior concrete under 10 inches of asphalt, and they repair it on a yearly basis. When I asked them why, they said, because our concrete doesn't hold up, freeze thaw, it doesn't hold up to salt. I mean, there's little metal spikes on the tires, and it just disintegrates. So we found that it's cheaper to put a soft, forgiving material on top, and we're gonna just keep putting more of that on over and over again. Well, after we spent a month there, I was invited to do another presentation. A university over there tested my material with me in their lab, because Estonia, Tallinn, the Nordic regions, Americans exaggerate. We need to see it ourselves. And I'm glad to say that after several years of testing, we're now pre-approved in Ukraine. We're approved and recognized in Estonia. So Estonia is the Baltic regions. So what my wife and I see happening is more applications for nuclear, more applications overseas and here, more applications for rail, more applications for nuclear. Offshore platforms, they lease the ocean land for 25 years, knowing that at 25 years, the whole thing's falling apart. Well, it's not the solution. Nuclear is better. But if you're going to put a platform out in the ocean, put something out that's going to last hundreds of years, right? We see all of that right around the corner, and we've paid our dues, and we've gotten ourselves pre-qualified, and we've got certified in other countries, and we want to. I want to continue to work with Steelike forever, but we'd love to have an organization pick the ball up where it is already successful and take it to a level within several years versus us sticking to the path we're on. It could take over a decade. I want to get the material. We want to get the material in the hands of somebody that can accelerate its benefits that are already have been proven.
Just with respect to some of these initiatives at the company, now, just to be clear to the audience, the company obviously there is revenue generation here. Obviously,
Sure.
there's costs and there's expansion costs and there's market growth costs. So my understanding here, Bill, is most likely that it's not like it's a company that's constantly generating positive cash flow on the bottom line on net income, because you have a lot of money to reinvest on that growth. But the company does have sales. I think that's important to point out to the audience. It's not like it's a junior mining company that does nothing but burn through capital, and there is no result on actual sale of minerals extracted from the ground, finished and sold off to an
Sure.
end user. That's for sure a difference here I wanted to point out. But
Yep.
also, what you said as far as how the company moves forward, there's probably a number of mechanisms that could be approached here, and that's what I want to get into next. Is as you can imagine, of course, we have a larger portion of our audience that is a broad demographic of investors, as well as participants in the energy and extractive businesses as well, that are probably listening in here to our podcast. We know we have quite a wide demographic of folks that listen. But talk about the structure of the company as it stands today in terms of the capital structure of the company. It is private, but that ownership, and if the company remains open to investors, and of course, investors is collectively lots of different things, Bill, but just talk about that ownership and how you see some of the things that you're open to.
We're open to everything. We're open to proceeding in the direction that we initiated. The beautiful thing about this material is it is blended, and it's like Coca-Cola. Only my wife and I know the ingredients. So our blender doesn't know 100% of what he's blending. The cost of blending is significant. If we had all the time in the world, I'm approaching 64, I would start blending my material myself. The the margin that could be recovered by somebody internally blending it would be significant, and put Steelike in an even more aggressive position with certainly a U.S. I've already been communicating with Estonia. They have about 50% of the proper ingredients over there. So we've already invested a lot of time looking at the future growth of going A, beyond bridges, and B, going overseas. So the way the company stands is my wife and I see the child who's ready to go to grad school. They've already did their basic college. And we want to find the right grad school. And that grad school is a little more expensive than we can pay for today. Does that, in a roundabout way, answer the question, Andrew? I want to make sure I'm answering your question.
So we have a demographic of individual investors. We have institutions that listen to us. We have mining executives, energy folks in the energy industry, whether it's organizations, utilities, traders, a lot of different folks that listen into our stuff here. Just in general, that it appears you guys are open potentially to a certain class of investor. Obviously, that would be accredited investors, but then also proposals on partnerships with folks, joint ventures. All of those things are essentially on the table, and then you guys would take it on a case by case as folks reached out with potential proposals or interest in investing. Is that correct?
That is correct. And we would be open to discussing anything. We're not closed to selling. We're open to it, but we would be picky because I would want to, if possible, I'd like to, and they would probably see the benefit of me staying on board. But we're open to everything you have discussed. The interesting part is we've also, as you mentioned, we've invested a lot in R&D, and that R&D has been proven successful and has been utilized on projects. So we're not just an R&D company. There are so many additional things that I would like to pursue in addition to basic infrastructure, shelters, tornado alley. We can, you know, as in your mind, I held up that 308 bullet stopping at an inch. You could precast panels, put them in hallways throughout the United States. If there's a hurricane, get the kids in the classroom behind, get the kids in the hallway. They're protected by Steelike. If there's a shooter, get the kids in the classroom behind 1-inch walls that can be any color, any shape, any style, any texture. The door frame is Steelike. The door is Steelike. Uh, and there's just so many additional directions I see the potential for. Tornado Alley. It just keeps going and going. Um, that catastrophe that happened in Florida, they still haven't written the report on it, but all those failing columns could have been encapsulated with a couple inches of Steelike, and the building wouldn't have fell down. So I have this spiritual quest and giving back energy that I would like to also pursue. So yes, we'd be open to conversations with a strategic. It would need to be the right one. So we're open to any of the things that you mentioned.
Collectively, you're here to look at the whole brand, and that brand includes both personnel IP, yourself, for example, and others at the company, but also all that data, all those approvals on specifications, the superior mix designs, all those things. So there's a lot of components to consider here and a lot of different types of IP, goodwill, and branding, if you will, that come with it.
Yes, sir.
And then, of course, the applications. I mean, for me, precast is a huge application, and precast can be used in a lot of different industries. The energy industry is a very substantial application that can work and make a lot of sense for a lot of infrastructure builds, conventional reactors, for example, other types of supportive industry equipment, fuel cycle, for example, if we talk commercial nuclear as well. Just to follow on to that, if there is someone listening in, Bill, and they want to engage the services of Steelike, or they want to understand the application of UHPC to their project, how can they get in touch, and what would be the process?
I'm going to go old school and new school. I'll start off with new school. My email is our website. So it's Bill. I would like them to send it to me at Bill at Steelike, one word, one L.com. And then I'm going to go even older. My cell phone. I welcome calls. I enjoy this stuff, as I think you can tell. I get excited about it. 609 703 2020, 609 703 2020. That's in the United States. And they could also reach out to you, Andrew, if they have any challenge getting me.
We've already mentioned the website, and that'll be displayed for the audience, but any other key areas that they should take a look at as far as social media outlets, Twitter, X, LinkedIn, or any other places you guys are active where they can see some of your guys' work in action?
The easiest way to do it is I have a personal LinkedIn page and I have a company LinkedIn page. The majority of followers, contributors from all over the globe, all different backgrounds, go to my personal page. So if you simply go to LinkedIn and search for William Kulish, Kulish, you will see you'll see my page with several thousand followers and contributors, and you also see a link to the Steelike page itself. That one is challenging because for many years before I created Steelike and before I created the Steelike LinkedIn page, I had my own personal page, which is turned into a business page. It's all about Steelike for the most part. So that would be another way. Facebook is Facebook, Twitter is Twitter. We have a pretty good presence on social media. Easiest thing to do is open up your browser and just type in Steelike UHPC, and you're going to see articles, videos over the last decade. Um, a lot of publications. We were just awarded the best UHPC in the United States, the most innovative, UHPC in the United States, and you'll see that recognition on my LinkedIn page, soon to be on our website. And then, as always, you can certainly reach out to me directly. And there's publications that the FHWA has done where they do actually mention Steelike. So if you go to fhwa.com and do a search for UHPC, you're going to see a lot of reports, tests, publications, recommendations, and you will see multiple summaries that do actually include the word Steelike. Why? Because they did a publication on pumping and spraying UHPC. Nobody else is doing it. So they were able to actually mention, now they probably mentioned my name, Bill Kulish, but that is Steelike. When you look at the most recent publication of AASHTO that I mentioned for the scripts that they have, the cover of that AASHTO publication has a Steelike girder on it. Whenever you see white UHPC, it is very safe to assume it's Steelike.
Bill, thank you for that additional information. Looking forward to seeing some of the audience reach out to you on this as well. And really appreciate you taking the time to talk to our audience today, and want to wish you best of luck at Steelike and expanding the business and delivering more UHPC solutions to the marketplace. Thank you for the time.
Thank you, Andrew. It was a pleasure. It's great speaking with somebody as knowledgeable as yourself.